First of all, welcome all of you to our talk, myself and Karin. So I'm Mary Grygleski, and this is Karin Wolok. And we came from the US, although Karin is also living in Tel Aviv too. So that's us. And today our topic is actually a bit more about data analytics, although then we would get into the tools that you can use to build data analytics solutions. So title of our talk is Optimizing Speed and Scale of Real-Time Analytics Using Apache Pulsar and Apache Pinot. Let's kind of get to this slide. If you're interested in in our slide deck right now and kind of follow along looking at the slide deck, here's the bit.ly link for it, also the QR code, although I'm not sure if you'll be able to scan it, but it is here. Otherwise, too, we'll be sharing this with you too later, and then also with the organizers too. So I'll give a minute for you, or 30 seconds for you to. Okay, I think folks are ready, right? Yeah, okay. All right, I'll make sure. I think some of you are still taking a picture or scanning, right? Yeah. Okay, good. All right, and now we'll have some introduction first. And who is Karin? Yeah. So Karin, okay.
Hello. Okay. So I'm Karin Wolok, and I lead the developer community for a company called StarTree. We're like a managed solution around Apache Pinot, and yeah, that's the story.
Oh, that's it?
That's my very long introduction.
Okay, yeah, okay, then thank you, Karin. And then who is Mary? So I'm Mary Grygleski. I'm a streaming developer advocate at DataStax. So this is a company that's based in California, although we have folks working even from Italy too, and then other places too, all over the world. And we're a startup company, and if you are into Cassandra, you may be aware of us because we have our managed cloud platform for Cassandra. And then a year and a half ago or so, company started to do event streaming and then brought in Apache Pulsar. So I'm the developer advocate for Pulsar. And then prior to this too, I spent about 3.5 years at IBM as a Java developer advocate and also with the WebSphere open source team. And then I'm based out in Chicago. I'm also the president of the Chicago Java Users Group and also a couple other meetup groups in Chicago. And if you're interested in joining our meetups too, we are still doing the online meetups. So let me know, or you can search for us, Chicago Java Users Group on the internet and find us on meetup.com. My background though is I actually spent over 20 years as a developer, engineer. So I'm really like understanding too the pains sometimes, right? And also the joy and pains of supporting software running in a company. Operation side as well as development and technical architecture. So that's me. Okay, that's me.
Wow, you put my intro to shame.
Oh, no. I think, no. Karin is amazing. Karin is
that's the best intro.
Manager. Yeah. So, okay. So this is just a quick agenda to give you an idea how we're going about this presentation. And as such too, right, Karin and I, we met because of the partnership too between DataStax and StarTree. There are a lot of synergies there because as such, right, event streaming platforms can be used for many purposes, and one of which, is the growing need for addressing real-time analytics. And then StarTree is now also using Pulsar as a data source as well. So today, too, we'll first start with trying to understand the problem domain that we are in, right, about real-time analytics. And so Karin will talk more about the real-time analytics, some of the use cases, and also the evolution of real-time analytics, and then what can we do and how can we do it? It's basically using Apache Pinot, and so Karin will introduce that and then giving you some pointers to how you can go about working with Pinot. Then we'll kind of talk about the real-time in data ingestion using Pulsar. So then I will be introducing to you a bit about Apache Pulsar. So yeah, so with that we can start, and yeah, so Karin, yeah.
Do you want me to take a clicker from you?
Oh yeah, sure.
No, the clicker. She was getting ready to give me her microphone. She's like, I'll give you everything. Okay.
Okay.
All right.
Okay.
So first I'm just going to go over some basic fundamentals, okay? So generally speaking, there's 3 types of analytics use cases. The first one is dashboards and BI tools. This is the most popular, most commonly known forms of analytics. It's usually used for internal purposes and usually analyzed by BI analysts and things like that. The next one is machine learning. This is basically any type of real-time analytics or just analytics in general. It's usually real-time. That's coming in, that's usually processed by some kind of machine or system. And then sometimes there's people there too, right? But it's a lot of it's like fraud detection and anomaly detection, things like that. A lot of times are fed into a system like machine. And the third one is user-facing analytics. This might be like a new concept for a lot of people, even though you're probably familiar with what it actually is once I explain it to you. So this essentially is when companies are building applications for and offering their end users or their customers access to their own real-time analytics. So why should you care? So in this specific talk, we're going to dig in a little bit more about user-facing analytics, specific use cases. And this is kind of just going over of like how businesses have transformed their business basically through user-facing analytics. So, initially it started out where analytics were being used primarily internally. And then over time, organizations started offering their end users access to their own analytics. And it's even gone beyond that where they started productizing their end users' real-time analytics use cases. And there's actually now companies, which I'm sure you guys are probably familiar about, where like that is literally what they offer is analytics to the end user, right? So there's a lot of like capability to empower your end user there, and there's also like engagement reasons and all that kind of stuff. But it's like transforming the business of what you're offering your end users. And I think I'm going to mention something else in here because I don't think I have a slide for it. But the one thing to think about when you're talking about user-facing analytics is your end users. There's a concept called actionable insights, and what that is when you give the ability for your users to take an action based on some kind of real-time analytics or real-time insight that they learn. So I'm going to go over a couple like basic use cases of real-time analytics that are used internally and externally at organizations, and I can kind of dig in a little bit more into the actionable insights and what that means. Okay. Oh, so I guess this does have the animation in here. All right. I moved things around because I thought there was no animation, but okay. So LinkedIn has real-time like user-facing analytics everywhere. So if you've ever used Who Viewed My Profile, that's a really good example of user-facing analytics. You have the ability to obviously see who you viewed your profile right now, like up to this second. And the users also have the ability to slice and dice this information based on company or geography, things like that. So this data has a lot of dimensionality. So this is like a really good example of like one of their premium features, right? Another example is the news feed. In terms of like a real-time analytics feed or like a system, not a real-time analytics system. A feed is like, this is a really good example of one. So essentially like, so a user clicks their homepage, they have to see information that's relevant to them that they haven't seen before and that's fresh, right? And then the third one, this is like very much productizing the user-facing analytics is like all their recruiter and talent insights where, the recruiters have the ability to see this like bird's eye view of what's going on in the talent market. And this has like a lot of dimensionality. I mean, this data is very, very wide. There's all kinds of like, it's very complex to build these kinds of systems out. So this is an example of one like organization that does real-time user-facing analytics really, really well and profits very, very well off of it. Another example is Uber Eats. So Uber Eats has a restaurant manager tool where they basically offer 500,000 plus restaurants the ability to have the bird's eye view of what's going on inside of their organization. They could see item feedback, inaccurate orders, missed orders, things like that. When we're talking about this actionable insights kind of thing of like empowering your user to be able to take action or do something based on the real-time insights, if they see that something is amiss or like there's some ratings are going down or there's like, if there's an inaccurate order, something's going up or whatever, they can take action right away, right? You can't give that data to them a day later. It's kind of useless at that point. But if they have the ability to act upon seeing that immediately, they're actually able to send their user, like their customers, hey, like, we realize this happened. We're so sorry. We're going to correct this. Here's a $10 coupon or whatever. But they're able to address it immediately, which is where you're essentially empowering your users by having real-time analytics and actionable insights. And the third example, I really like this example. It's less external real-time analytics, but more like internal, but it still has the same kind of dynamic of like the systems of what you need to build with these real-time analytics use cases. So Stripe is a financial payment platform. Essentially what they're doing when they're building these real-time analytics systems out is they have on one side internally dozens of engineering teams that are working on all different parts of the platform. And they need to be able to take all this data that's coming in from all these different teams, bring it into one aggregated view, and then make it accessible in real time to dozens of other internal teams, like the accounting team, the fraud detection team, like the data science team, things like that. So they're building these real-time analytics systems that are functioning similarly to the user-facing analytics use cases, like by pumping in all this fresh data and then pulling it back out. So talked about a little bit about the trend of internal-facing analytics and then user-facing analytics and how things are shifting. And what's happening is also the requirements of like when you're building these things, the needs that you have to fill are much more, bigger, for lack of better words. I didn't have any coffee today. In terms of latency, everything's expected to be like milliseconds now. Like the data freshness has to be seconds. Like your users are not going to wait around for things. And then another thing that makes building these systems quite challenging is that the concurrent amount of queries that you have, like the queries coming in at the exact same time for all these end users, this is quite complex versus just offering it internally, right? In some cases, you have hundreds of thousands of queries at the exact same time. High dimensionality of queries and whatever. So, okay, this also is like another thing of like of how the real-time analytics world is changing from internal-facing analytics to user-facing analytics. How like structured data and now it's like semi-structured data. Everything has to be strong data consistency and query consistency, full SQL semantics, and also like our data. Obviously, data size is exploding. I don't need to tell you guys that. But there's a lot of shifts that are happening in the system. So building a user-facing real-time analytics system, there's essentially, I don't know if we don't have a slide for this. So essentially there's like 3 things that you have to kind of consider when you're building a real-time analytics system. So the first part is real-time ingestion. You have to make sure that you're pulling in this data in real time, and it has to be as like very, very fast, right? As close to real time as possible. And then the second part is you have to make sure that your querying speed is also in real time, right? So like you have to be able to ingest this data very fast, but you also have to make it accessible very, very fast. And then the third part to it, which is the bottom, is that it has to be scalable. You have to be able to support hundreds of thousands of queries coming in at the exact same time, all in real time. So ingesting in real time, querying in real time, and doing it at scale. And then I'm going to hand it over to Mary right? Oh, okay. Yeah, so Mary's going to talk about the first component of what it takes to build a real-time analytics system.
Okay. All right, so I think I'm just going to talk a little about Pulsar, then you have a couple more slides on Pinot too.
Yes.
But anyway, so next thing is then how do you do real-time ingestion, right? So that's when we want to suggest using Apache Pulsar. If you can see, I mean, actually one of the pains too, I mean, I don't mean to be like comparing, different things, but the thing is, a lot of folks too, I believe, are using Kafka. Or may I see a show of hands, who of you, are using Kafka, for example? Yeah, okay, yeah, I'm aware too of a lot of folks using Kafka as a data like source or streaming. It's very popular. But how many of you have heard of Pulsar or working with it? So yeah, okay, so a few have heard of, and then a few, yeah, working with Pulsar. So that's when I want to start introducing to you Pulsar. It's definitely a more cloud native ready platform. And one of the things, though, is with Kafka is that you have all the offsets to deal with all of your consumer messages in your consumer group, all of these things, and no more of that kind of like a complicated, unnecessarily complicated things. Basically, Pulsar, too, using a cursor to kind of like go back and forth in your log messages, too. And not only that, it's very cloud native in nature. So as you can see too over here, this is just a high level diagram. You have producer and consumer talking to a broker, and you can have multiple brokers. Your topics can be partitioned across like different brokers, so you increase your throughput. The thing with Pulsar is that it also separates the compute and the storage. So then the storage part, all of your log messages are being handled not by Pulsar, so that Pulsar can focus on dealing with all of the compute side of things. And then have Bookkeeper. Apache Bookkeeper is the one that deals with manage all of these huge volumes of log messages. You write them to disk and making sure they are there, that you don't lose them. And then how do you, kind of coordinate them? Of course, there are a lot of complexity between coordinating the two, but they work together very well. And then also too with Bookkeeper too is that it segment off all of your log messages into like different, they're actually managed by different bookies, and then each one of them are managing different segments of all of your log messages. So that's kind of a quick kind of introduction first of Pulsar. And I think the next thing is that, this one too. So this is actually the slide too. It's basically showing you that for real-time ingestion, we like to suggest you using Pulsar. It will give, the velocity of ingestion, the high dimensionality of all of the data that you need. And then this one, I think then we come back to Pinot. So yeah, I know.
Okay, on the other side of the coin, so Apache Pinot is an OLAP distributed data store. So essentially what it's built to do, so it was originally built at LinkedIn. And what it's built to do is it's built to ingest data from a variety of different sources. So like streaming, batch, and then you pull it into one kind of like merged aggregated view. And then it has a bunch of different types of very powerful indexing techniques that allows you to also make that same data that you're pulling in, this like historical and real-time data, accessible for queries at very, very high throughput with very, very low latency. So if you have a lot of concurrent queries and you need it very, very fast, that is what it's built for. Yeah.
I think it's still
okay.
yours.
So I guess, cool. Okay.
Sorry.
All right. So I'm going to click into this a little bit. Okay. So actually, I'm going to use this slide because it's a little bit better. Okay. So this is just about a little bit about like the Apache Pinot architecture. So you have the Pinot controller, which essentially just kind of manages everything. You have Zookeeper, which is basically for your metadata. I'm wondering if, okay. It doesn't have the colors on here. That's all right. That's fine. It doesn't matter. The segments have colors associated to it. But okay, and then you have your Pinot brokers. Your Pinot brokers, your Pinot brokers essentially are taking queries coming in from the clients, and then they use like an intelligent scatter gather method to be able to access this data in like the different Apache Pinot servers, which are down at the bottom. So you have the ability to basically, the Zookeeper also has like a mapping system from like segments to servers, and then you can kind of set it out on different servers. So it's like a distributed system. And that's like the high level overview. I don't want to dig too deep into this because I know we kind of don't have that much time. So as I mentioned, Apache Pinot is built was built originally by LinkedIn, and it's like very widely adopted. It's a very mature product. Actually, Slack users over 3,000 now, and like 100 companies, like probably ones that you've heard of, like let's see, Walmart and Target and whatever, 7-Eleven. Okay, and also in terms of like performance, the largest Pinot cluster is currently, what it was performing at, this was at LinkedIn, I believe. It has an ingestion rate of over 1 million events per second, with a query speed of 250,000 queries per second, while maintaining a millisecond query latency, which is pretty powerful. What's the next slide here? Oh my God, you put all my slides here. I'm like, why did I miss this? I was like, okay. So there is a bunch of indexing capabilities inside of Apache Pinot. Like at the heart of Apache Pinot, it's a columnar store. But there is a lot of different types of indexing capabilities: inverted index, sorted, range, JSON, text, geo. And then there's also aggregation, optimizations. And then also in the bottom, there's a StarTree index. That's like the company that I work for is called StarTree. Yeah, we're like the people who originally authored the project are the ones who created it. So essentially the StarTree index is kind of like this happy middle between indexing and pre-aggregation. So it has like kind of this ability to be able to do pre-aggregation for things, but you also have like a threshold. So it serves as like this very powerful place between like pre-aggregating queries and still maintaining low overhead. And there's like a bunch of content online if you guys are curious into digging into it further. It's pretty cool. And there also are different levels of Pinot specific optimizations, from like the storage level to like the filter level. And yes, this is like insert any real-time analytics use case here. You can use both Apache Pinot and Apache Pulsar together to be able to tackle the real-time analytics use cases. And I don't need to dig into this one too much, but here you can.
Okay, all right. So now it gets to the point we go back to talking about the real-time ingestion and then using an event streaming platform that actually helps you to do messaging beyond just the messaging, meaning that we're gonna really deal with streaming of data, the streaming of many event streams that are coming in, right? And essentially, yeah, in my individual talk too on event streaming, I go a bit into the basics first. So I'm assuming everybody is familiar with events and event streaming. So I'll skip over that part and get straight into the event streaming. So basically too, we're saying that, well, what is driving the change, right? If you kind of just talk about event streaming and event messaging, they're kind of dry topics, right? And so what do you use it for? You go back to your work group, right? And saying that, well, I learned something, but how can we actually use it? How can we make the value out of using something like this? So essentially too, right, the very good, perfect case would be using it for real-time analytics. So the real-time capability is what we're going after by using a streaming platform such as Apache Pulsar. So it helps too, because the effect of such is that if you have real-time data coming in, you basically can react to it right away. For example, like fraud detection system. You don't want to wait, right? If you sense that something is wrong in your bank account, you want to be alerted right away. So that's the value and like an event streaming platform can bring to you. The real-time aspect, right? You get immediate results. Also, too, you can use it to build artificial intelligence or machine learning pipelines, data pipelines, right? For example, like your machine learning, you want to immediately be able to analyze the data as it comes in. Then you also derive from this change of data, the machine learning model that you want, and deploy it right away. That cycle is really in milliseconds, for example. So you can leverage on like event streaming type of platform to help you ingest all the data and then do something like data analytics and then process it right away. So that's the idea. So helping you to build data pipelines. And another thing too about like an event streaming platform such as Pulsar is that the pops-up approach too will help you to scale the input of your data really well. Like if you have tons of data coming in, for example, even IoT type of application scenario, you have many devices installed in a field, for example, and collecting data, temperature changes, and all these things. They keep sending data to your server. That scalability, you need to be able to meet that. So using something like an event-driven type of approach like PubSub basically can allow you to increase your number of brokers to handle all of your data and then have topics being partitioned into different brokers and increase your throughput. And that's the scalability aspect is unmatched, because when you're dealing with PubSub kind of data, the publisher, you don't have to worry about what address do I send the data to. I let the broker take care of things for me. I only tell the broker, this is the topic of this data. How do you channel it? It's up to how broker deliver the messages for you to the consumers who are interested in the data and subscribing to that topic. So that's the idea. So again, this is just summarizing, right? It allows you to watch for the events of the system and you only subscribe to the topics that are of interest to you. and allow you to also make decisions in real time, not after the event. Allows you to also ingest high frequency of messages with very low latency. So that's the goal. And now then it's Apache Pulsar. So what is Pulsar, right? And I have to assume a lot of you may not have heard of it, so I'll do a bit of introduction, so bear with me for those of you who are familiar with it. So Pulsar is actually created by Yahoo back in like 2010, so about 10 years ago. At the time too, they have to deal with Yahoo, all of the services, right? And deals with large amounts of data, and also they live in the cloud and different cluster. At that point in time, the cloud was still kind of new. So a lot of these things, they realized, okay, at that time, the distributed messaging platforms weren't there. And whatever distributed messaging, the message queue, for example, all the queuing software are not able to handle things in the cloud. Because anytime you deal with things in the cloud, how do you balance the load? How do you, when you increase the nodes in your infrastructure, how do you, spread out all of your data accordingly, all that stuff. So then Yahoo decided that, well, we're going to develop our own library. So they call it Pulsar. And then by 2016, they decided, okay, it's time to open source it to Apache Software Foundation. And then very quickly, it became a top-level software in 2018 because everybody is recognizing its value. At that time, too, I think Kafka is already kind of aging, right, so to speak, because Kafka was designed before the cloud time, so to speak. So Pulsar, in fact, has a very cloud-native DNA, or I should say, already, cloud DNA in its system, right? So it knows how to handle all of these things. And essentially, too, it's already cluster-based. Also, it supports like multi-region. You can divide up all your data by tenancy, and so a hierarchical kind of organization of all of the data. You segregate them out accordingly, right? And then also, the nice thing about when the Pulsar system is that you actually are not forced to know a certain language, for example, like Pulsar. In fact, you can write your client in Java because natively Pulsar is written in Java, the broker and everything. But in terms of client, you can have .NET client, you can have Python or Go, and there are also community client libraries, contributions such as like Scala or Ruby, all of these other things too. So you can check them out too. And then also too, the message delivery part too. Pulsar takes care of guaranteeing all of the message delivery. There are like message expiration, time to live, all of these things are also being taken care of. And bear with me, this is kind of high level stuff, I understand, but I only have like 10 minutes to talk about it. So, okay, so, and then another thing too is that anytime you develop a system, right, in a data pipeline, you ingest the data, and very often too, you want to do some transformation on the data. And then you may be thinking of, well, what should I use? Should I write my own thing to transform it? But for Pulsar, we have actually a library, or within it, right? There's also this package called Pulsar function. So essentially, it got inspired by like AWS, the Lambdas, and Google pops up their functions. And so it's essentially its own kind of function library. It's also got very simple interfaces. You can extend them and write your own functions that you can transform through the pipeline. So that's the idea. So there's Pulsar function. And then there's also the concept of tiered storage offloads too. So anytime, right, you have processing tons of log messages, and then they become cold because then maybe they are staying, you get processed or not processed still in the queue, and they get cold, and basically Pulsar knows it and will move it offline to cold storage too. So all of these things, Pulsar is actually very flexible in helping you to deal with working in the cloud. And so then you as developers, you don't so much about all of these infrastructure. Okay, so this is just a slide. Again, what is Apache Pulsar? If I sum up, it would be called like a unified distributed messaging and streaming platform. And it's open source, and it's also very cloud native ready. And I have a couple slides on discussing what are some of the advantages of using Pulsar. And also over there on the right-hand side, I know it's kind of a little hard to see, but they just show you the graph of the popularity of Pulsar. It's since, I think 2017 or something. So you see there's a rise of interest, number of stars on the GitHub repository, a number of contributors are all growing too at this point. So it's still kind of significantly a lot of interest in this library. Also, you may be wondering who else is using Pulsar. So here are some of these. These are big companies in all kinds of industry. Yahoo, Comcast, and Verizon, all these things. And a couple companies in China as well. They are kind of in the communications area, also are using Pulsar. So, okay, so now then discuss a little bit then about Pulsar, the components. So they're a producer. This is essentially Pulsar is by nature is a PubSub system. PubSub as such, right, is an architectural pattern. So Pulsar implements it its way, but it follows the pattern of you have a broker. The broker is a serverless process in the middle, sort of important too because it coordinates everything, right? It deals with, talking to bookkeeper, talking to zookeeper, all of these things, and then of course producers producing messages, and it's up to the broker. It functions like a postmaster. Like a post office, right? And you need to deliver the messages on behalf of your client, which is the producer. And then if you're interested in the messages, will be the consumer subscribing to those topics that are of interest to you. Then the broker will deliver them accordingly. And of course, too, in the PubSub system, when you deliver messages, it's not just like getting a message and deliver. There are many rules too, right? Sometimes you have to say, what's the time to live period, or like, is it retained messages or last will messages? All of these things, broker will kind of handle it for you. And then again, there's also bookkeeper, which is the one that takes care of handling all of the log messages. Think of it this way, right? The really big plus about it is that then Pulsar is kind of free of having to worry about all of the log messaging. How do you deal with, going back to read all your log messages again? So Pulsar has a reader interface too that you can go in. Essentially, it makes use of a cursor interface. You can actually look into all of your messages too afterwards, right? That type of stuff. It retains all of your messages until your client acknowledges it too. So that's bookkeeper. So bookkeeper is actually doing a fantastic job, and it is kind of all the heavy lifting duties of managing all of these heavy duty like log messages. Bookkeeper is doing a good job of it. And then there's also Zookeeper too that Pulsar relies on for helping to manage the cluster metadata, all of your Pulsar instances in different cluster or different nodes, all of these things. So Pulsar kind of coordinate with Zookeeper and rely on Zookeeper to help you with that. There's also leader election, for example, right? In any kind of distributed systems, you have different nodes. Not every node should be making decisions. So you have a leader algorithms and relies on like Zookeeper, the Zookeeper, what is it called? There's a Zookeeper leader algorithms that it relies on to kind of pick the leader in the nodes to kind of make decisions and who's to do what type of thing. So, okay, so this is actually a slide to just give you some background knowledge about Pulsar. It actually follows a traditional multi-node architecture. So it allows to then, you can do horizontal scaling kind of easily in the sense that it hides all of the complexity for you. And if you add a node into your infrastructure, it knows how to distribute and rebalance all of your topics across the different cluster. And that, if you do it in Kafka, it would be kind of hard to do. You need to worry about the offsets and all of these things. But Pulsar actually does it for you, and it rebalances it for you, and that's a really big plus. So I want to emphasize that. And then also, too, in this case, you separate out the concern. Pulsar, we worry about the messaging side, have Bookkeeper worrying about the storage side. Okay, so this is just another slide, but primarily just talking about Bookkeeper. It follows this write-ahead logging specification too. So all of the log messages, they are fault tolerant and low latency, storage, all of these things, it handles it. And then if you are into Bookkeeper, that type of computing, right? Storage computing kind of terminology. There are like the write quorum, act quorum, ensemble size, all of these detailed things. Bookkeeper kind of does all of these things for you. And it actually has a thing called ledger too. That is kind of, think of it like accounting. If you know of accounting practice, you have a ledger that keeps track of all of your actions and transaction account. So it has the ledger that helps like managing all of the data, the log messages essentially, and then also kind of spread them out and segment them off accordingly. So this is just a summary. Again, Pulsar represents the next generation of enterprise messaging, and it's a unified solution for PubSub. You can also do queuing, and I'll quickly show you how. If you want to turn it into a message queue, you basically, on the subscription side, you can use the exclusive subscription, and that turns Pulsar into like a message queue for you. And then there's also streaming part, right, obviously. And then also the message mediation and enrichment part you can do through using Pulsar functions. Okay, so some key differentiators that, again, I already talked about separation between compute and storage. That's actually a big plus. I don't think any other libraries are, for doing event streaming, able to do that. They're not designed to kind of separate out the compute and storage. I don't think so yet. Not as good as Pulsar. And then the next thing too is that about Pulsar is that it has a feature called geo-replication. So especially if you're in a large company, you have different data being like, in different data centers that are the world, for example. So you need to replicate all of your data across, in your whole world, the different regions and everything. And sometimes too, there are certain data, for example, here in Europe, you have GDPR, and in America, we don't, or kind of less stringent, right? And so if you want to replicate data, maybe certain data you don't want to replicate across the globe to non-relevant areas. So Pulsar already has built-in capability. You can configure it. You can kind of replicate what you need and that type of stuff. So everything too about the active, passive, all of these things, you don't have to do a lot of manual process, and Pulsar already has it available for you. You just need to know what you need and then configure it accordingly. And then there's also this concept of multi-tenancy. If you have data that you want to be able to separate them out by department, if you have product department, engineering department, you have different data, you want to kind of segregate them out, you can actually kind of group them by different tenants. So they're in multi-tenancy. It helps with like scaling, the security, the compliance aspect very well too. And then, okay, so this is the one about a very flexible messaging processing model that Pulsar has. Basically, it's on the subscription side. You can have like one of four modes of subscription that you can have, right, for your consumer side. You can have what's called like exclusive mode. So basically, you specify only one single consumer to be the one that's subscribing to your topic in that case. And because of that, then you turn it into a one-to-one type of point-to-point type of messaging, then it turns it effectively into a message queue kind of capability using the exclusive mode. And then there's also a failover mode. If you want to ensure that you have primary consumer, and then if the primary goes away for some reason not working, you have a secondary that kind of takes over too. So ensuring like high availability, making sure there's somebody that's able to receive the messages. And then there's also this mode called shared mode. So shared is essentially you allow multiple consumers per subscription. And then if you also want like messages to be delivered in the order that it was received, right? Or actually, I should say, message gets delivered and you want it to be consumed in the order that it was received. You can basically use the key shared. So it basically also kind of keep track of your key and then know the order of the messages too. So that's also something that if you need it, it's already there, kind of built in for you. You just need to make sure you use the key share mode. Okay, so this here, just a quick, just a couple kind of highlighting a few features. I talk about Pulsar functions, and here is just a little illustration too. Actually, it is working. And by the way, sorry about a bit disorganized because the Wi-Fi isn't working here, so we weren't able to get to our slides, but then we're able to somehow get it. So it is here, it's a little different, that's why. But anyway, so this is working, but I want to illustrate too. We're building data pipelines, and think of this kind of way of dealing with your data is pretty flexible because you can have different chunks of source data and then do the sync, kind of like that. So this is like an example of a source to sync kind of thing and using Pulsar in between. Because here in Pulsar, you're transforming the data as it comes in using perhaps like Pulsar function to do some small transformation, filtering, for example. And then when you're ready with the data, you can output it what we call to a sync, kind of like that. So as such, you can use Pulsar functions, and it allows kind of complex streaming processing. It's very lightweight. It's inspired by AWS Lambdas and Google Function too. And the main languages at this point we support are Java, Python, and Go, but there will be .NET support and other languages as well. And then there's also this feature called Pulsar Schema. So as we know, if we do distributed messaging, the message will have to go through over the wire. So in that case, then you have to serialize your data before you send it and then deserialize it when it comes back. So it's a bit of a pain in the neck, right? As developers, you just want to do your thing, So you can actually use Pulsar schema. So in other words, you define you kind of use Pulsar schema, and then basically when it goes to send the data, Pulsar would take care of things over the wire for you. Otherwise, too, you have to always make sure your data is byte arrays when you before you transfer it, kind of like that, and then convert it back to the structure that you want. So you can use Pulsar schema, and that also keeps track of the data as it changes in versioning it for you and managing for you too. And also, to the types of data, it supports all kinds, like primitive data types, or key value pair, or Afro, JSON, protobuf. So yeah, it's pretty flexible. And then there's also this thing called Pulsar IO library that allows you to essentially write your own sync. I talk about these syncs, right? So what are syncs? So they are the ones that kind of receive all your data on the receiving side in your data pipeline. So if you, currently too, we have pre-configured like Kafka sync, for example, or pre-configured like RabbitMQ sync. But if you want to do a sync that hasn't been pre-configured, you can actually write it using Pulsar IO. And it's also just a library, it's a simple interface, you can write your own. For example, people asking me some old things like terracotta data or something I didn't even know, you basically can look into it and develop your own connector too. Okay, so this is just a quick thing about DataStax flavor of Pulsar. We have Astra Streaming, which is actually we manage cloud platform. It's with the Cassandra, and there's also Astra Streaming support. And currently we offer $25 US dollar per month for using it for free. And then there's also Luna Streaming, which is you host your own using Helm charts and deploy it yourself. And then you can buy our enterprise support, or you can use it all open source too. So those are the different rates. Okay. All right, so I think then we're kind of, almost end. And so let's see. So where to go from here? And please keep in touch. So this one is actually the resources for Apache Pinot. If you're interested, it's here, pinot.apache.org if you need more information.
Yeah, and the dev.startree.ai also has a lot of resources, but you can also join the Slack and just ask questions that have already been asked. That's fine too.
That's right, thank you. Okay. And then this one is all the resources. Of course, there are more too, but if you want to start looking into it, there's pulsarapache.com, Bookkeeper, Zookeeper, and then on DataStax side, we have our AstraDB sign up. Again, you get, you don't need to give your credit card, just sign up with your email address and you can immediately play around with it. Unfortunately, I don't have time today to kind of demo it, but if you're interested, let me know. And then here, there's also extra AstraDB, essentially managed Cassandra in the cloud and with streaming, and you can get extra like $200 in credits too using that code. And also we have our DataStax too. We have 5 minutes about Pulsar. Currently we started publishing them and just different topics in bite size. So if you want to visit our YouTube DataStax developers playlist, it is there as well. It's kind of dynamic. We're adding topics to it every month. So, also I have my own Twitch stream if you're interested, because here I cannot talk about some of these coding details, but in my Twitch stream usually it's once a week if I'm not on travel. It's on Wednesday afternoon if you want to join and follow me on my Twitch. And then also we have our neighborhood, Pulsar Neighborhood Meetup Group, and also our wiki page, Apache Pulsar Neighborhood as well, that you can contribute to, or you can read up on the different topics. And then with that, yes. Yeah,
there's one other thing that's it's not on the slide deck, but I just want to mention it. We're hosting a real-time analytics. It's like a free virtual summit thing. If any of you guys are interested more about real-time analytics stuff, it's RTA, like real-time analytics, summit.com. So
thank you.
That's it. And Mary's going to be speaking at it too. So.
Oh, thank you. And Karin will be hosting. So yeah.
That's right. I am going to be hosting,
Thank you.
which is like, be scared.
Yeah. Thank you.
But thank you guys so much.
Thank you. And just so you know, we also have Grace too in the picture.
Yeah, Grace is in there.
Yeah. Yeah. Okay, so go to Grace Talk. Thank you. Thank you all. We're right on time. Thank you. Oh, thank you. And if you like, I also have some Pulsar stickers if you like. Yeah, I have stickers here. Let me see how I can. Let me I'll put it on the table there, maybe if folks wants to. If you're interested in getting some stickers. I don't know how, but I'll just put it over there. Oops. Okay. Oh, thank you. Yeah, I have more too, but I just grabbed a few right now. Yeah, if you need more, I have more too. So yeah. Okay, thank you again for coming to our talk.